okay, my video got cut off and I didn't get to do the bottom part. So I'll just add it as a second video. All right, listen, you guys remember that cosine and sine are complementary to each other? Well, what do you think this means? If you compare sine degrees to sine degrees, they have to be supplementary, right? And the reason why this happens is when you're trying to do the area. If I go back to that triangle like that I gave you in the do now, this happens when the height comes on the outside, right? When it comes on the outside of a triangle. And the reason being is, in order to find the height on this side over here, if I'm going to use this angle as A over here, but I want to figure out what the height is, I actually got to switch, and instead of doing the angle on the inside, I got to do the angle over here on the outside. What's the relationship between the inside angle of A and the outside angle of A? Their relationship is their linear pairs. What are all linear pairs? They're supplementary. So on a triangle like this, if I need to go through and find the height, I need to do the sine, not of the inside angle of A. I got to actually subtract it from 180 to get it supplemented so I can get the linear pair and then do it on the outside to get that. Now, it's a little weird. You know, you're not going to see that very often, but it's a possibility that could happen. And the whole point of it is to show you that if you compare sine to sine, right, they're not equal in measurement. They're not 90 degrees. You know, the angles aren't equal, all right, and they're not equal to 90 degrees. They're equal to 180 degrees. So, for example, all you have to do to figure out any of these problems is if it's telling you to compare sine to sine, sine of 23 degrees, what degree is it going to be equal to? Obviously, it's itself, but the other option is the linear pair to it, all right? So, what's 180? All right, okay, what's 180, all right, minus 23, it's 157. So basically, you have supplementary sine angles, and they're equal to each other. And again, I don't know if you guys watched, what was it, Tuesday's lesson? Watch this. Compare them. What's the sine of 23? Sine of 23 is that, 0.39, right? Okay, all right, well, what's the sine? What was it, 157? What's the sine of 157? See how it's the exact same degree measurement? And that's because when you're trying to find the height, you have to use the opposite side and you want to get the height of the triangle. So the height is going to end up being the same length. So the opposite sides should be the same length. So whether you do it on one side of the triangle or the other side, which could be on the outside, you have to find their linear pairs. That's the reason. That's it. So for like all of these, right? Okay. So let's do this one. Sine of 67. All right, what's 180 minus 67, right? 113. Okay. All right, you want to test it out. Sine of 67 is 0.92. Sine of 113 is 0.92. They're the exact same thing, right? So again, just, you know what? 180 minus 87, it's 93. Okay. All right, now I'm feeling a little silly. Oh, shoot. Do you notice that I'm not comparing, on this one, I'm not comparing sines anymore. I'm doing the sine and cosine. Do you remember what the rule is? These are complementary, right? So complementary, I got to do 90 minus 53. And this one's 37. So just be careful. This is from Tuesday's lesson, all right? Sine and cosine are complementary when you compare their angles, right? Sine compared to itself, you get the same measurements when you do the supplementary of it, right? Supplement. So basically here, sine of 53, right, is that, and I got to do the cosine of 37, and it's that. Remember, the opposite side and the adjacent side are equal ratios, right? They're the same length, right? When, you know, you do the opposite and the adjacent side, but that's sine and cosine. So here, let's do 90 minus 76, 14. And finally, I got one that I don't even have to think about. I could do it in my head. It's got it, well, it's not that, it's 40. See, I can't even do it in my head. Okay, you guys can make fun of me all you want. All right, but my video got cut off, you know, so there you go.